Hi, I'm Shane. Welcome to my shop. Welcome to my channel. Today we're going to be machining this shaft, which has an integral gear, and going over how to spec it out and machine it. This is for a recently rescued from the scrapyard, very nice Fosdick radial drill press. This thing has so instead of just having a box, it has a table that goes up and down, which it makes for a heck of a lot nicer of a a working height for the drill than say like my Cincinnati Gilbert over here, which I love, but I'm a little jealous of the Fosdick. It's a really nice piece. Another feature that they had, there's dials on the headstock that you can set the depth for tapping that you want the tapping to stop, and the wheels will hit a momentary switch and reverse the spindle up to the second setting on the dial, which is where you would set completely out of the cut, and it'll spin it back forward again. So you just keep moving and tapping holes. It's a really cool feature. It's a really cool drill, and it's in pretty fair shape, and it was way too nice to go to the scrapyard. I will put some pictures of it in the intro here. But if all that sounds interesting to you, I mean, by all means, stick around and see what we got going on. But yeah, thanks for checking out the channel, and thanks for coming back to the channel for all you guys. I really appreciate it. Appreciate the support. So I guess without further ado, the intro. Alright, so basically what we got here, this wheel goes on this shaft, is held in place by this number 3 tapered pin. And this gear, you can see, drives this gear, which drives this helical gear, which runs on a rack. I'm assuming the purpose of this gear setup here, well, it almost has to be to change the direction this wheel spins, so that it's a little more intuitive when you're running the machine. It just feels a lot better to turn this wheel clockwise and have the machine move out towards the edge of the arm. Counterclockwise will bring it back towards the column, and it just feels I'm pretty sure that's what this whole setup is meant to do. I initially thought that I was going to have to cut this helical gear back here, which is fine. We can do that. Actually, if you want to see on that and you're new here, feel free to go back and check out. I have a series on cutting helical gear for a Walker Turner bandsaw. That's what that whole series is about. That goes over your theory, the mathematics involved, and the operation of making a helical gear on a horizontal type milling machine, or universal type milling machine. So definitely check that out if you haven't seen it. I'll warn you that some of the production quality isn't so good. I'm still getting the hang of this. I think I'm doing better now, but it's still pretty good, pretty informative video. So next I'll take you over to drawing that I made up, speccing this out, and explain how and why I chose the tools, order of operations, and how I figured out, my center for this hole, I guess, is a key point. So hang tight, and I'll bring you back on the other bench over here. All right, so this is pretty straightforward. As far as these lengths and diameters can be measured with your standard micrometer. I choose to use a 10th micrometer, like a veneer micrometer. so I can get as close as possible with what I have to work with, which is pretty good stuff. It's done me good so far anyhow. um, we just get our thickness of this. Um, the gear is your 375 thousandths, so 3/8 of an inch, and then we measured the overall. Most of these measurements, it's good enough to use a nice dial caliper like that. And one of the reasons is you don't have a lot of clearance for a micrometer. Your diameters, you definitely want to use micrometer. This diameter, this. But I opted to use these, to determine with my tapered pin pressed in, the thickness of my taper pin. And then half that, and then get a measurement, from this edge of your taper pin, as tight as you can, to the edge of your workpiece. And that will locate the center of this hole within, I would say, within a thou or so, which honestly, in an application like this, if it's too loose, we can shim it. If it's too tight, we could set up the wheel on the surface grinder and clearance it that way if need be. Honestly, it should be close enough to function properly and run good. Next thing we had to figure out, we got to figure out what diametral pitch cutter to use. So what we're gonna do, I'll just use used a micrometer, but I'll just use for illustrative purposes. All right. You want to get the major diameter of your gear. All right, and then you can't use that diameter. You need to use the pitch circle diameter, which we obtain by subtracting it. In this case, see, in most cases, pretty much half of your tooth depth, and you need to account for clearance. But in all honesty, you're losing a couple thou by going straight across the teeth, because you're kind of cutting off the circumference of this circle. All right, so there is specs for how much clearance a cutter should have, and we know what we kind of double check that because our cutter tells us how deep we're supposed to go, and use that loosely too. The reason these 185 thousandths thread wires are here is for to get an actual measurement, from side to side. There you go, clear up a little bit. Selected this wire because it meets kind of right in the middle of the involute portion of the gear, and that should give us a fairly accurate gauge of how deep we are and how much further the cutter may or may not have to go. So put these on an even tooth gear. You can kind of see there's a tooth adjacent from another tooth, which means there's also a slot adjacent. A lot of times on an odd tooth gear or spline setup, if this was odd, like there would be a tooth adjacent from this slot. You just go with that. Where that differs when you're measuring it or machining it is in even, you're going to take half of what you measured because it's coming off of both sides. But on an odd number, you're only measuring the depth of one side. I hope that makes sense. So what you read is what you need to take off on an odd tooth gear. All right, and this is all just ways to be redundant and make sure everything's on point We don't want to do it twice, and we certainly don't want to mess the part up. So we did the math on that, determined it's going to be a 12 diametral pitch. The pitch circle diameter is just under 1 inch, and with these, with these cutters, you need to you're going to round up or down, pretty much, I guess is the best way I can say it. But you can see kind of a rudimentary way of double checking how nicely that fits in there, right? And it's going to be kind of more on that angle as it's cutting through the tooth, but yeah, that sucker fits, perfectly, so I don't have any problem. I'm sure that's the right cutter. And we'll go to depth that I measured. I did measure a depth with a depth mic, and like I said, you're cutting off the circumference there. But I'm going to go to that depth first for my cut, which is around 170 thousandths. The cutter calls for 180, and then we'll measure it with our thread wires and just bring it on home nice and easy, so that if all goes well, we have a perfect fit the first time. Aside from that, the material we're going to be using in this case is I have a piece of 4142, which is kind of a pre-hard 4140, which will machine. You should be able to get a better surface finish on that, as it's harder. Annealed 4140 normally it gums up on you, and your finish suffers. So I'm hoping that works out a little better for these portions, because there are bearings that are snugly fit on here. I wouldn't say press fit, but they're they're right on size. You had to tap the bearing off, so you didn't have to press it or anything, I guess is what I'm saying. So we're gonna make sure that all works out well, and I think we can get a more than adequate finish for bearing to ride on here and here. There are recesses. I would tend to think that they are just reliefs, like they may have ground this. So you got a heck of a shine to it. So they may well have ground this, but I don't think it's necessary in this application. It's not under real high loads. It's not going to go really fast. It's going to be fine the way we're doing it. What I will do, on the off chance that this is here for lubrication purposes, which by the casting over there doesn't look like it is. When I face these sides, that'll be, after turning, I'll face these down to get all these measurements, and I will leave a little recess, with the during the facing operation. So, and that should be more than sufficient. Other than that, we don't really need a center on here. I have my dividing head with the 3-jaw chuck dialed in within a couple tenths, so I just don't move it pretty much. If you're not sure, you need to do that anyhow, but if you're not sure of how good it runs with a chuck, you should do this between centers. The center we're going to need is this outboard center, as this will be on the tailstock, and we will chuck this end. Last operation is going to be locating and drilling this hole for a tapered pin, and then we will ream it with the handle. So hang tight. I guess I'll get this piece of 4142 chucked up in the lathe. I'll probably show you guys, dialing that in with an indicator and everything, because that's always cool to watch. So hang tight. I'm going to get you over to the lathe, get chucked up, and we will start cutting this largest diameter. Okay. Alright guys, so I reviewed that last clip. One, I rabbit trailed a little bit there. I never really got to the point that I was trying to make with the finding your diametral pitch. Um, so your pitch circle diameter. All right. Uh, Real quick way to find out what diametral pitch is. You need to find your pitch circle diameter. All right. The way we're going to find that, we're going to take one hole tooth depth and subtract that from our outside diameter. In this case, we end up right around an inch. All right. So we have 12 teeth. So we're going to subtract um, our number of teeth by our pitch circle diameter. That's how we obtain the 12 diametral pitch. Second thing is, I've been having a lot of trouble with, I've been using the Synco system for my wireless mic, and I cannot get the feed. I've changed cables and everything, so there's a little bit of feedback in the last couple clips, and I apologize for that. Moving forward for this video, I'm just going to go without, and I hope that the sound quality is okay. I'm going to try and speak, project decently so you can hear me. But yeah, I got to find a different system. So that's that. That's enough talking. I'm going to get you over to the lathe. We're going to do some machining. All right, hang on. All right, we got you set up on the lathe. I already screwed it up and drilled the center, put a live center on it. Now we need to take this piece down to our first diameter. It's going to be 1.172. We are currently sitting at 1.245. So we'll get to turning. I've got WNMG 432 insert. Spinning 480 RPM, which is the max for this lathe, at 11,000 feet. So, all right, here we go. See how she reacts. Alright, so basically my dial indicator wasn't quite long enough, so I used a set of calipers and I measured out, put some die cam on, and I scribed a mark on the piece. I'm going to turn it till I'm close, and I'm going to face the rest in so that I end up with a nice finish on both sides of what will be the gear. So that's where we're going now. Alright guys, so I lost a little bit of video. The phone that I record with died, but you can see we got the gear blank cut. Basically, I measured against the original, and I used a set of dividers to mark out, each step and transition. Obviously micrometer here and here, and here, and then I used a micrometer to get my 310 thou gear thickness. But everything's just about right on spec, no more than half a thou out. And I fit, that's where the handle goes. I fit that up. That's a nice snug fit. Bearing, can we see it? bearing's a nice snug fit. So I think we're in good shape here. Next, I'm gonna charge my phone and then record cutting these 12 teeth on the horizontal and how I check that and everything. So yeah, that'll be that. Let me get situated here, and then I'll set the mill up to cut the teeth, and I'll bring you back. All right, guys. So we're over at the mill. We're set up. Dividing head has a plate with 60 holes. It's a 5-to-1 head, so way you figure that out. Basically, the 60 times 5 revolutions is 300, and we need 12 teeth out of it, so we divide 300 by 12. We end up with 25 hole spaces that we need to skip each time. Went ahead and set my sector arms to do that. Bring you over here. We're set on center, and the way that I do that, on something small like this, it can be difficult. Let me get you set up real quick here. So basically, you want to measure your diameter of the piece that you're cutting. All right. In our case, it was 1.171. Being as this is really small, I can't line the side of this cutter up with the side of this workpiece. So what I do, take something like this little brown and sharp square, and you can offset this cutter to this side. I had to come in from underneath, but you can kind of use that as a straight edge on your cutter until you'll see a little bit of movement up here. You'll be able to feel it. You'll be able to see it. So bring that in so you know that this edge is touching with this flat, dead flat against your cutter. All right. So we're going to take our radius of this, okay, and then we need to add half the width of our cutter, because that's how far we're going to move over from being out here. And the width of the piece, this happens to be exactly an 1/8 inch, or I'm sorry, a 1/16 of an inch. So this is 62.5 thou. So like I said, radius, all right, plus half the width of your cutter, because you're measuring off of this edge, plus whatever it is you use, to establish the edge of that. It seems to work really well. And then moving forward from there, what I normally do to obtain my zero for touching the material, use it's an older beat up set of feeler blades, but 5 thou feeler blade right in against till you feel it get snug. And when you set your zero, just dial it back 5 thou. So you're 5 thou before zero. So when you actually hit zero, you should be contacting your work surface. It's kind of arbitrary at this point, because we're going to start at our zero, measure it, and then determine what we need to take in addition. We're not going to take the full depth. You always want to give yourself some cushion. You can make 2 or 3 passes, however many you need. Yeah, in this case, I think we're probably going to take, because of the smallness of the piece, and there's only 12 teeth to cut, so we'll probably do just short of half depth, and then bring it to near full depth, measure it with those pins that I showed you previously, and we'll bring it on home from there. do kind of a finish pass. Try and get it within 10 or so thou. Horizontal gives a great finish no matter what. Yeah, almost every time. So that's what we're going to shoot for, where we only need to take a couple thou off to finish it out. And I guess that being said, we'll fire the mill up and start taking our first cuts. Alright, so we're currently spinning at 90 RPM and we're going to be traversing at a half a foot per minute feed rate. So, see how she does. Like I said, I took half depth of the required, and I'm just going to go short of the extra half and measure it and come in for our final. So, here we go. Alright guys, so this is our first pass. We did 84 thou, which is half of our 85 thou, which is half of our 170 thou depth on the cutter that it calls for. We're going to go to 160 thou and we're going to measure it with our pins. So going to raise it up and I will bring you back. Alright, hang tight. Alright, this is the last pass of our second pass. So we're going to see how this works out, and then we're going to measure it. It's expected to be somewhere around 24 thousandths over yet. We'll get to that here once I get done with this cut. On the tooth, they're looking pretty good. I don't know if we can see them or not. They're all very uniform. They do look a little shallow, and they should, because we should have, in theory, we should have 12 thou to go. In reality, we're going to find out. That's why we go a little short. Yeah, so we can double check and hit the numbers perfect every time. We'll just go to the same line of our cutters all the way through the cut. Give it a second to make sure we got it. We're well past the center line. We're going to get out of the cut. That's what we call it. Get as much of this oil off as we can. Alright, we'll get our pins. This is going to be kind of tricky here. I guess you guys can't see a whole lot, can you? Alright, let's see if I can. There you go. Let's see, they look pretty nice. There is some, see, if you were climb milling, it should take all these burrs off. But what we're going to do, we're just going to run it on our cheap wire wheel, and that'll knock those right off. But we are going to tape our bearing surface so that we're not scoring that up. Let me see if I can get this measurement quick. I may have to bring you back because it's kind of difficult to work around you here. Let me walk on the back side and see what I can do. Alright. And these are two adjacent ones. Just wiggle it in. Alright. See what we have here. Yeah, we are 1.348. You can see that. So really close. So our 10th thou, that'll get us to 11th thou. I don't know why that took so long. It was a long work day, but so there we are. 11th thou depth of cut, as we are 22 over right now. So we'll advance another 11th thou and finish her out. All right, guys. So here's our finished product, minus the taper pin hole. So original, ours, replacement. Came out a thou oversized with our pins, but I didn't see as that was, you know, a real critical part. There's probably some wear in the one we measured off of, and ultimately we took the 170,000th depth of cut that was required by the cutter. So I'm gonna say we're good. Put them together. Let's find a clean one here. I mean, these things look like they were cut from the same piece. So, you know, I think we're well within any tolerance for this machine. I will mention, I believe cutting this pre-hard 4140, it did dull my cutter a little bit. It still performed well, but it left a pretty gnarly burr on the back side. Perhaps if I climb cut the finish pass, it would have helped because it would have drove the metal into the part to break the chip. But what I ended up doing, I popped it in the lathe really quick, and I snugged up a parting blade, and I just knocked the burrs off the back, which was because this is hard. I couldn't file it. I couldn't use a dur bearing tool. It just wasn't happening. So that actually worked out really good. Couple things I want to mention. I didn't say anything about. I didn't show you guys setting up the mill, but regardless of how good you think that or repeatably accurate your setup is, like my dividing head with the chuck on it, how I use the 3-jaw chuck more times than I use the centers, always double check that, because you don't want to make the part twice. Um, in both planes that it can be out, you want to double check that. Two, I wanted to point out a really cool part. I'm not sure what all dividing heads have it, but I thought it was worth mentioning that oftentimes when you're dividing, at least with the Kearney and Trekker, I know the Cincinnatis don't have it, at least the older ones don't, but every 10 holes on the Cincinnati plates, they have a bullseye around the hole, which makes something like that really easy, because in this case I was going 25 holes. So I could see visually that I was on my that I jumped my 20 holes, 10 and 10, and I was either on every other division, it was either 5 holes past one of the 10-hole bullseyes on the plate, and every other one was directly on. And it's always good if you do have that and you find that kind of situation to double check your divisions. It's a heck of a lot easier than counting all of them, I guess. But yeah, she turned out really good. If you can see that. I'm happy with it. It's got a good finish. Next thing we got to do, we're going to set it up on the Acra mill. Probably going to fit it up inside all of this, and I'm going to get a mark with it set up where the center of that, where the transfer punch, where that pin should be, and then I'm going to compare it with the measurements that we have on our drawing when we spec'd out the original part. Okay, so I'm going to do that and probably bring you back on the Acra. I may change my mind. I may show you setting it up and transfer punching, but we're getting a little lengthy here, so I may just get right over to the Acra and fit it up. All right, hang tight. All right, guys, we're set up on the mill. We're indicated flat. I have the piece mounted in a little TMX V-block. Center finder in. We're going to find the center. We're going to find the edge. From the edge, I'll zero it here, and we want to move in 947 thousandths. I think I may take 945 and give myself a little bit of room. Yeah, basically that's what we're going to do. We're going to find our center, zero it out, switch to a chuck, and run a center drill. Come on, focus. You know what it is. And then we're going to run, I believe, an 11/64 bit, which is a hair smaller than the smallest size of the hole, but it's about right for number 3 tapered reamer. Now we're going to run the reamer and let it center itself in. Alright. Well, let's find a zero. We're just going to advance that guy right there until it kicks. Right there. screws up to our y-axis. Zero that. Enter. We're going to find the other side. We're going to zero it, and we're going to half it. Alright, so I got my chuck in. I have my center drill. I know that that center drill is 300 thousandths in diameter, so I measured it. So we need to take the radius of that eventually here. What I'll do, I'll run this snug against. Boom. Right there. Not a lot of give in it, so just now I'll take my x-axis. I'm gonna zero it. Alright. Drop my knee down. I'm gonna move over 150 thousandths and I'm gonna re-zero it. And that should put me. So I'm gonna move over. Oops. 150 thou. That should be half of the cutter. Come on, buddy. $150 thou. All right. Now that tip of that cutter should be dead center on the end of that part. I'm gonna take my x-axis. I'm gonna zero it again. All right, now I know that I need to step over the what's say 945 thou. So I'm gonna do it. And this being hard, we're gonna have to be run really slow. 945. Come on. Whoop. We're gonna have to run really slow. Come on. Losing my mind here. 945. I think we're close there. Alright, so we're going to run really slow and we're going to use lots of coolant so we're not burning up our high-speed steel bits. But it should cut right through this. Alright. I guess I'll set you up quick and I'll get back to it. Alright, so we're in our 945 thou. We're going to fire up and we're just going to a super nice hole. Alright guys, so basically what we did here, we drilled our hole to the smallest size for this reamer. We lined our holes up and we're just going to ream it. We're just going to keep reaming and we're going to let it open up until it starts to take a little bit of material out of this piece. Try our paint out. I don't want to overdo these things either. It should drop right through. We can go a hair further. I think that'll pin nice. I think that'll pin really nicely. Matter of fact, I think we're gonna get a little bump here. Oh yeah, that's perfect. So, I'm gonna say that's about it, man. That's a wrap. Try and get you some pictures here in a future video with this what this drawer ends up looking like. But the buddy's doing a really great job on it, so I can't wait to see it either. So that's that though. So if you enjoyed, don't forget to like, Subscribe, tell your friends about it. If you look back on past videos, there's a constantly accruing horde for a 1,000 subscriber giveaway. Feel free to check out the other videos on my channel. And thanks. I hope to see you here again. All right. I believe that's what it's supposed to do. Very little free play. Very nice fit. So, just one small step in saving a classic Fosdick radial drill. Alrighty.